Dear students, in this video we are going to learn about doubly linked list. Okay, doubly linked list is a type of linked list in which each node contains a pointer to the previous node as well as the next node of the linked list. So this is the picture which shows you how the doubly linked list is created. As per the definition, here we are having two links. One is representing the previous node and another one is pointing the next node. Okay, so that is what the name doubly linked list. Okay, so this is the no code snippet for creating a node. So each and every node, as per the concept of the linked list, we must have two components. One is data, another one is the pointer which points to the next node. So in a doubly linked list, we are having additionally one link. That link is denoted here as prev. Okay, so this denotes the link for pointing the previous node of the current node. So each and every node of the doubly linked list must have three components. One is data, another one is the next pointer which points to the node next to the current node, and the previous pointer which point to the previous node of the current node. Okay, so while creating a node, we are supposed to create a node with three components. One is data, another one is next pointer, then the previous pointer. Okay, so obviously we will be creating the linked list with the class called init class, where DLL list is named as the class name, and we have a method, init method, where we initiate the creation of the head node. Okay, then insertion operation, as like our normal linked list operations, here also we are able to perform insertion and deletion operations. Okay, so insertion means we are going to insert a new node in an already existing node. So here in this insertion shown in the PPT, we are trying to insert a new node as the first node of the linked list. That is, we are trying to insert a node at the front. So already we are having some sort of nodes like A, B, C and D. Each node has its next pointer as well as its previous pointer. The first node A, it has its next pointer which points to the node B, which is next to node A, and its previous pointer, there is, since it is the first node of the linked list, its previous pointer early points the null value. That means there is no other node previous to the node A. So this is the first node of the linked list. Now we are trying to insert a node called E, so that the notation should be as such: the null pointer of the first node, earlier first node, that is A, should not point to null now. It should be redirected to point the new node. Similarly, the next pointer of the new node should obviously point to the earlier first node, so that the first node now becomes a second node of the linked list. So this is what the link denoted here. Then the new node's previous pointer should point to the null value, because the new node's previous pointer points to the null node. Null value means that there is no other nodes previous to that. Okay, so this is the head node, or this is the first node of the linked list. Then the pointer head should point to the node E instead of A, because E is inserted as a new node of the linked list. Okay, so this is the insertion process at the front. So the link changes is very important here. So this is what denoted in this code to new node equal to DLL new node. No, that means DLL node, we are creating a new node with its data, and new node's next pointer should point to the head. That means earlier head is A, so it must point to the head node, that is A. Then head dot previous equal to new node. That means the previous pointer of the head node, that is A. A's previous pointer must point to new node as shown in this diagram, and head equal to new node. Obviously now the new head is the new node. Okay, so this is what the process of inserting a node at the front of the linked list. Okay, the next one, insertion at the back. Okay, so how we are able to insert a node at the back, that's what we are going to learn. So obviously we need to traverse the list and identify the last node of the linked list. So how we can identify the last node? The last node's next pointer will always point the null value. Okay, the first node can be identified by the next previous pointer of the first node will be always pointing the null, so that we are able to identify that is the first node. Similarly, the last node can be identified by its nature, that the next pointer of the last node will always pointing to the null value. Okay, so we need to traverse the list right from the beginning by using some temporary pointers. Okay, so here it is denoted as PTR. PTR initially point to the first node or the head node, then the pointer will keep on moving to the linked list. Then when it finds the current positions or current nodes next pointer point to the null value, then it identifies that it is the last node. So that here we can insert a new node by changing the link like the next pointer of the last node, that means current last node should point to the new node. Okay, then the next pointer of the new node should point to null value, then the previous pointer of the new node should point to the current node where the pointer is located. Okay, so that means it is the previous last node. So this is what the changes we are supposed to do in the linked list in order to insert a new node at the end of the linked list. Okay, so this we can denoted here, that this we can see in this code snippet as, then we are checking that if of head, that means there is some node should be there. So if we are having the head node, then we are assigning a pointer temp to head, that means head is assigned to pointer temp. Then while temp dot next, that means when, until and unless temp dot next pointer pointing some node, we are supposed to traverse the list. So that traversal is denoted here as temp equal to temp dot next. Okay, the next one is the new node dot previous. The previous pointer of the new node should obviously point to the current temp, right? That means what, temp is currently located at the last node. Currently temp is currently located at the last node of the linked list, but we are going to insert a new node at the end, so that new node becomes the last node. So new node dot previous equal to temp. So previous pointer of the new node is assigned to the current position of the temp pointer, and temp dot next should point to the new node. So this is what the condition of inserting the new node at the end of the linked list. Okay, so we have seen the insertion operation, inserting at the beginning, that is at the front, insertion at the end, and the third one is inserting the element after some ith node. That means after some ith position, after some particular nodes, we are going to insert a new node. So how this insertion is happening here is, as usual, we need to traverse the node list right from the head node. We need to identify the node, identify the previous node of the node to be deleted. Okay, so the previous node of the node to be deleted should be connected with the new node, and the links connected with the current node or the ith node should be disconnected, and it should be taken care by the new node what we are inserting. Okay, so that is what given in this code. We are traversing the list, we are identifying the previous node of the current node or previous node of the position where we are going to insert a new node, then that new node's next should point to the current nodes. That means the previous the node to be inserted node, so that temp node's next pointer. Okay, so new node dot next, new node's next pointer should point to the temp nodes next. Temp pointer is currently in B. Suppose if you want to insert E in between B and C, the temp pointer as of now points node B. Then we need to relink the next pointer of the new node E to the next node of the current temp. So next node of the current temp is C. Okay. Similarly, the current temp's next node's previous pointer must point to the new node. So that is what denoted here, temp dot next dot previous. So temp node is as of now B. Its next is C. So temp dot next dot previous means the previous pointer of the node C must point to new node. Okay, so that is what the case. So next one is temp dot next equal to new node. So instead of connecting B with C directly, we are connecting B with E, and E is connected to C. So thus it inserts a new node in the middle or in the ith position. Okay, I hope you are able to understand this difference while we are inserting a new node at some ith position. So in order to insert a new node at some ith position, that we need to traverse the list, need to identify the previous node of the ith node or ith position, and the previous node's next pointer should point to the new node, and the previous pointers new node's previous pointer must point to the current node where the temporary pointer located, and the new node's next pointer should point to the next of the current node, and the next node's previous pointer must point to the new node. Okay, so this is what the case of inserting a new node at the ith position. Okay, then deletion operation. So obviously we are removing some elements from the linked list. So first node, if you want to delete a first node, obviously the head pointer should move from the first node to its next node. So that is what head dot next dot previous. So that means what currently head pointer points node A. So head dot next means it should point node B. So next node's previous node, that means node B's previous pointer must be assigned to none, because we are going to delete the first node A. Okay, then head equal to head not next. So the new head will be the node B instead of node A. Okay, if there is nothing, no more elements in the list, then head equal to should be pointed as the none, because there is no other element. There was only one element that also deleted now. Okay, as a first node of the linked list. Then deletion of the last node. So in order to delete the node at the last, obviously we need to traverse the list and need to identify the last node. How can we identify the last node? Temp of, that means we are using a pointer called temp pointer. The pointer's next node should not be null. So if it is null, it indicates that it is a last node. So until and unless the particular pointer pointing the node whose next pointer points the null value, the list should be traversed. And in order to delete the last node, the previous node of the last node should be previous pointer of the previous node's previous pointer of the last node should be connected to what? Next pointer should be connected to null value. So that is what given here, temp equal to temp dot next. So this will helps you to traverse the list. Once after you identify the last node, temp dot previous dot next. That means what? The temp is as of now D. Previous means C. So previous dot next means node C's next pointer must be point to null value. Then head, that is what the case. that this indicates that the node D is disconnected from the list, and currently node C is the last node of the linked list. Its next pointer is pointing to null value. Okay, so this is the process for deletion of the node which is located at the end of the linked list. Okay, then deleting the ith node. So how we are able to delete the ith node means, as like or insertion at the ith node, we need to traverse the list and we need to identify the position I, then we need to locate or we need to change the links of the nodes of ith positions previous node. Okay, so we are traversing here, we are identifying the position I, then then the previous temp dot previous dot next equal to temp dot next. So for example, if I want to insert a new node at the beginning at position B if I want to delete a node C, then its previous node is B. So previous node's next pointer should be point to next of the node to be deleted. So B's next pointer should point to D, and next the nodes temp nodes next pointer points D now. So its previous should point to the previous of temp. That means what? D's previous pointer must point to pointer B. B's next pointer must point to D. So this is what the linking changes we are supposed to update in order to see the result of deletion of ith node. So now since C is disconnected from both B and D, it seems it is deleted. Okay, so this is what the case for deleting the ith node. Okay, so far we have learned about the doubly linked list. So in the doubly linked list, it is possible to insert, delete at the both the operations are possible. Insertion can be taken at the front, at the back, as well as the inserting at some ith position is possible. Similarly, deletion also can be carried out at the beginning, at the end, as well as the at some particular position. Okay, based on the requirement it can be executed. Thank you.